Hi, Assalamualaikum. Today we proceed to the last subtopic for Chapter 1, 1.4 Charges in a Uniform Electric Field. So in this subtopic, we are going to learn about the movement of a charge when we place it in a uniform electric field. Okay, so remember before this, we learned that in order to form a uniform electric field, we need two metal plates that are parallel to each other. So one positive, one negative. Only then we can form a uniform electric field. Okay, so what does it mean by uniform electric field? Okay, uniform here meaning that at any point inside the region, they will always have the same value of E, of electric field. That is what we mean by a uniform electric field. And remember, the direction of the electric field will always be going towards the negative plate. Okay, so here we have four different cases. Okay, we are going to look at it one by one. Okay, the first one is stationary charge. So stationary maksudnya dekat sini there is no movement. Okay, there is no initial movement. The velocity is equal to 0. So we just place a charge inside the uniform electric field. Okay, let's say here I place a positive charge. Okay, so when we place a positive charge inside a uniform electric field, this positive charge will move towards the negative charge. So it will move towards the negative charge. Why? Because we learned in 1.1 that the charge will have electrostatic force. So ada force yang menyebabkan the charge move towards the negative plate. Okay, remember before this, positive will be attracted to negative. So there is a force here. Kita gunakan Fe. Okay, electrostatic force. So as you can see here, the force is in the same direction as the electric field. So the movement is also the same direction as the force. Movement, kita gunakan simbol A, acceleration. So this is what happens when we place a positive charge. Okay, when we place a negative charge, okay, inside the uniform electric field, it will move towards the positive charge. Okay, dia akan attract kepada positive charge, Fe here. So the movement will be the same direction as the force. So as you can see here, the force is actually opposite direction as the electric field. So benda ni senang je lah mau faham. You know that when we place positive, dia akan attracted towards negative plate. When we place negative charge, it will attract towards positive charge. So kamu boleh, kamu tidak perlu hafal pun. Kamu just lukis and then you can see the direction here is opposite as the electric field. Okay, so in this case, the net force is equal to MA. And the force involved here is only electrostatic force. So ada satu saja force yang terlibat. And we learn in subtopic 1.2 that when we relate electrostatic force with electric field, okay, F will be equal to the charge times with the electric field. And the charge here is the test charge, this one. So apabila kita substitute this one, QE will be equal to MA. And then we rearrange the formula, we will get A, the acceleration is equal to Q times E divided by M. M here is the mass. So this will be the equation that we are going to use for the case stationary charge. Okay, so the next case is when we have a charge moving perpendicularly to the field. So the keyword here is moving perpendicularly. So meaning that there will be a certain value of initial velocity. Okay, so perpendicularly meaning that, okay, let's say if we have the electric field direction is going downwards, so the charge will move horizontally making an angle of 90 degree. Okay, perpendicular mesti 90 degree to the electric field here. So this will be the direction of the charge. Okay, let's see what happens when we have a positive charge. Okay, so we have positive charge with a certain value of initial velocity. Let's say 2 meters per second. Okay, so what happens is this positive charge will be attracted towards the negative plate. So when the charge enter the region, okay, when the charge enter the region, it will be deflected towards the negative plate and then it will exit with a certain value of velocity. So this movement, we call it as parabolic path. So it is different compared to the first case. So first case tadi, apabila kita letak positive charge, dia akan terus go towards the negative plate, right? Dia terus macam ni, tidak akan ada parabolic movement lah. Okay, that one is when we have the velocity is equal to 0, no initial velocity. But now we have a certain value of velocity. That's why dia tidak akan terus attracted macam ni, because there's a movement. That's why dia akan slowly going towards the negative plate and then exit with a certain value of velocity. So sama juga when we have negative plate. Okay, so right now we have negative charge. So right now we have negative plate dekat atas, positive plate dekat bawah. So direction of the electric field is going upward. Okay, so negative charge akan attract towards positive plate. So the movement is also parabolic along the parabolic path. So this movement is what we call as projectile motion, which we have learned in semester 1 before. Okay, so we also use the same formula as we learned in projectile motion, except there is a bit of, there's a certain formula that we need to substitute. Okay, so sama juga, when we have the motion of parabolic motion like this, and then exit with a certain value of velocity. So this is the initial velocity. So meaning that we need to resolve into x component and y component. So there is a vector v here. So apabila kita resolve to x and y component, okay, we have all of this formula. So untuk x component, vx akan sama dengan ux. So basically sama saja formula ni dengan apa yang kita belajar dekat chapter 2, projectile motion. Untuk vy will be equal to uy plus at. And uy will be equal to 0. Sebab this one, there is no value for uy. And u will be equal to ux here. So this one kita cancel. And then ada satu part we need to substitute with the formula from the first case. So acceleration dekat sini will be equal to QE divided by m. So ni formula yang tadi dekat case yang pertama. And then barulah kamu akan dapat this equation. So untuk displacement, we have Sx is equal to Uxt. So Sx dekat sini adalah the distance from here to here. This will be Sx. So nanti kamu akan tengok dalam salah satu example. And then Sy here is the same, you will get -1/2. This one kamu sudah masukkan the formula untuk acceleration times with t square. So we will look at the example later how to use all of this formula. Okay, next one, when we have a charge moving parallel to the field. So as you know that the direction of the electric field will be going towards the negative plate. Okay, so when we have positive charge moving, okay, with a certain velocity in the same direction as the electric field. So parallel kan dia cakap, so must be in the same direction as the electric field. So we know that this positive charge, okay, positive charge will be attracted towards the negative plate. So dia punya force juga akan sama direction as the motion. So since ada force yang tolak dia untuk bergerak dengan lebih laju. So we can say that this positive charge accelerates along a straight line. So this is for the case positive charge. So when we have negative charge, so let's say here we have negative charge going towards the same direction as the electric field. Okay, since negative charge, they akan attracted towards positive charge, so the force will be going in the opposite direction. So force will be going opposite direction. So since movement dia going to the right, and then ada force yang tolak dia going to the left, what happens to this charge? The charge will decelerate along a straight line. So this is for case number 3. Okay, so last case when we have a charge in dynamic equilibrium. So for this case, we need to consider weight force. Untuk case yang sebelum ni, we don't need to consider weight force. Kita hanya ada satu force yang terlibat, which is electric force saja. Untuk case yang keempat ni, we have two force, electric force dan weight force. Okay, so dynamic equilibrium here meaning that the charge will move with constant velocity. So this will be the keyword, constant velocity. So when the charge enter the region with a certain velocity, okay, since we want it to be in constant velocity without any deflection, so dia tidak akan deflect, okay, going in a parabolic path. So in order to maintain this, we have to consider the weight force. Okay, so here we have negative charge, right? So negative charge will be attracted towards positive plate. So force dia akan going upwards. So in order to balance this out, we have another weight force going downward. That's why this charge can move in a straight line. So in the same velocity, constant velocity. So here, the net force will be equal to 0. So Fy, the sum of force for y component will be equal to 0. Since tadi, the force going upwards, positive, weight going downwards, negative. So force will be equal to the weight. So force yang kita belajar tadi, in first case, force adalah sama dengan QE. Since dia adalah constant velocity, right? That's why kita sama dengan kosong. Okay, bukan sama dengan MA. So force kita adalah sama dengan QE, weight sama dengan mg. And then when you rearrange, you will get this formula. So untuk case ni kita akan gunakan this formula. Okay, so last one here, we have another formula in order to find electric field. So this formula is only for uniform electric field. So formula yang kita gunakan adalah E is equal to delta V divided by distance. So delta V here is the change in potential or potential difference. So this one only for uniform electric field. So distance dekat sini adalah distance between the plates here. So the distance between the plates here and potential difference usually will be given in the question. So nanti kita akan tengok how can we apply this formula in the question.